All right, so we have this drag racer that needs to get up to a speed of 135 meters per second from rest in about 5 seconds. We want its acceleration, and we need to know how far it needs to travel to do that. Let's go ahead and fill in what we know. This is a SUVOT question. I've got the equations here, and we're just going to go ahead and use them. So from rest means it starts at 0. The time is 5 seconds. The final velocity is 135 meters per second. We don't know its acceleration, and we don't know the time, or we don't know the distance it's traveling over which to do that. Let's go ahead and get the time first. Let's try to use v equals at plus v naught. And unfortunately, well, let's just see. V equals at plus u. So we have 135 equals a times 5 plus 0. And so we're going to end up getting 27 meters per second squared as our acceleration. Wow, okay, that's pretty fast. Well, I mean, it's pretty decent acceleration. It's almost 3 G's worth of acceleration. Now, let's go ahead and figure out how far it needs to travel to do that. So I'll use s equals 1/2 at squared. Whoops. S equals 1/2 at squared plus ut. So just let's put this in a box. Whoops. So there's the box. Oh, 19th time's the charm. There we go. 1/2 at squared plus u times t. Let's plug in our numbers. So we have 1/2 times 27 times 5 squared plus 0, because 0 times a number is 0. And this is going to end up giving us quite a big number, actually. I'm getting 337.5 meters. Yep. Let me try that again. 337.5 meters. So there's our answer for part A. Now for part B, people kind of got a little confused by the wording here. Let's keep this really simple. A student wants to calculate their height by dropping a penny from the height that their head is and timing it. They claim the penny takes a full second to hit the ground, and we want to know if their data is accurate. And I don't know why people were using this number in the calculation. Read the question again. We're saying we're going to time this thing for 1 second. The acceleration is 10. The initial speed is 0. We don't know how tall the student is claiming to be. And we don't know the speed at which the penny hits the ground. All we're saying is, why don't we see what this person calculates and compare it to our friend Sultan Kösen from Turkey, who stands 2.581 meters. So let's do it. Let's calculate the height that they're getting given their data. So that's going to be s equals 1/2 times 10 times 1 squared plus 0 times 1. And so that's going to give us a height of 5 meters. So the student claims 5 meters. So this is clearly not an accurate measurement. So no, because 5 meters is greater than the tallest person. So that's how we know the data is inaccurate. So that's problem number 4.